Welcome back to the Atoll FDP on Data Science, organized by Department of Computer Science and Engineering, B.S. Abdur Rahman, Crescent Institute of Science and Technology. I would like to give a brief introduction about our guest speaker, Mr. Dilip Muralidharan, Senior Technical Instructor, Splunk Chennai. He is an education consultant with a total of 18 plus years of experience in the IT industry, with 12 years of experience in consulting, designing, customizing, and delivering technical training on enterprises' IT software platforms. He is also experienced in working with customers across APAC, North America, and EMEA, with a proven track of record developing, selling, and delivering education solutions to custom fit the client partners' requirements. He is also experienced in business development, selling, and upselling education services. I would like to invite on behalf of the Department of Computer Science and Engineering to continue the session, sir.
Thank you very much. Good afternoon, everyone. Am I audible? Is my voice audible? Can someone confirm on chat if
Yes, sir. Yeah,
I'm audible?
you're audible.
Excellent. All right. So, good afternoon, everyone. Today, we are going to talk about the subject of security orchestration, automation, and response. So before we go ahead and talk about the subject, I would like to take a minute to thank the staff, the teaching and the non-teaching staff, and the management and all the individuals who help put together this session, people from AICTE, Atoll Academy, and from ICT Academy for helping put together this session. So just to start the session, today's discussion is going to be security orchestration, automation, and response. I've been given 90 minutes to carry on with this session. And in the interest of fairness, what I'm going to do is I am going to set my clock to 70 minutes so that I can have a 20-minute Q&A at the end of the day once we go through our lecture material and we see our demos here, right? So the subject today is security orchestration, automation, and response, or SOAR, as it is popularly termed in the IT industry. So primarily speaking, what we are going to discuss today is going to be nothing but automation from the point of view of security, right? So that's what we are going to see. Now, before I jump into the subject and I start talking about security automation, I would like to quickly introduce myself. I'd like to talk a little bit about my background to justify why I think I'm qualified to speak on the subject. So as introduced, my name is Dilip. I am a senior technical instructor with a company called Splunk. Splunk is one of the world's largest and leading big data analytics software and service provider. So we work primarily in the security space. To be specific, we work in the security space, specifically under the machine generated data space, right? I have been in the IT industry for about 18 years now, out of which the last 12 have been in the education and consulting space. So just to give you a brief history of where I come from, I started out with a company called Alsec Technologies here, which is a BPO organization, quickly moved on to Convergys, which is basically a support and back office operation kind of a business based out of Bangalore. And I supported Microsoft Windows desktop and server products over there. After which I moved to Trimble Navigation, where I supported GPS-based fleet management devices. So my biggest break was with Computer Associates, where I provided support for all sorts of storage and recovery management products. So mainly backup and recovery management and replication and failover and software cluster based products. So and then in 28, I moved on from support into education. I moved to EMC and I worked on enterprise content management systems. Then left EMC, went to JDA to do supply chain for about a year and a half. Eventually moved back to EMC, and now I am with Splunk. So at Splunk, I continue to be in the same profile. I am an education and consulting professional. So I deliver training. I put together education and consulting solutions for customers who buy products from Splunk. So that's a brief synopsis of my career history. So we're going to jump into the agenda here, and we're going to talk about SOAR, or Security Orchestration and Automation of Response. We'll talk about the applications for SOAR in business. And what I would like to do is, I always believe in a demo of how things work in any technical discussion that I have. And in line with that personal philosophy, I have a demo set up for you. So I do have a Splunk Phantom installation, and I'd like to build, very quickly build a simple playbook. And I'd like to show you how security can be automated from the point of view of, let's say, a particular business use case. So in this case, we look at a very simple business use case of, a malicious file that is being downloaded via HTTP from the internet onto a server, right? And we'll see what can be automated on that front. So, question, what exactly is security automation, right? What do we mean by the automation of security orchestration? Because you see, the field of IT security is pretty huge. One can keep talking about IT security and its use cases all day long, and one wouldn't be done, right? But beyond all of that, right, we are now in an era where automation is the norm in pretty much any and every industry, right? And when it comes to information and technology, the security business is, not any different at all. In fact, I would actually argue that automation as a concept, automation as an idea, actually came about to be first in the security space. That's where automation kicked off, right? So once the automation of security use cases were pretty successful and standardized, it eventually moved on to other business use cases, right? So before actually going into security automation, right, I would like to throw a couple of questions to the audience, and I would like to get a discussion going on, right? So I would like for the audience to comment, what are all the things that they do to secure their personal electronic devices? So when I say personal electronic devices, I would like to quote only 2 different devices so that we can keep our discussion limited and narrow in scope, right, and not deviate from the topic. So the most important, electronic technical devices that you might use today would be a computer. Now, it doesn't matter what kind of a computer it is, whether it's a desktop or whether it's a laptop, right? Whether it's an ultrabook, whether it's a very powerful workhorse machine, it doesn't really matter, right? So I would like to find out from you, right, what are all the security best practices that you practice, right, in order for you to secure your mobile devices or your laptop or desktop workstation devices? What are some best practices? Okay, one person says lock or password, antivirus software, antivirus, fingerprint, passcode, two-factor authentication. All right, Password is another example. All right. Okay. What else? What other best practices does everybody follow? Passcode. Anything else apart from passcode, pattern lock, antivirus, fingerprint scanner? Any other best practices that anyone can recommend when it comes to iris? Okay. All right, I'll take that. Iris scanners are not too popular, but they are popular in certain manufacturing and plant kind of destinations. Fair enough. Firewall, okay, using updated version of OS. Available in Samsung. I'm not sure what's available in Samsung. Is there a firewall that's available in Samsung? Iris. Okay, iris scanners are available on Samsung laptops or Samsung phones. What exactly is it? Okay, any other examples? Any other things that people do to secure combination of code and biological features? Okay. Hashing, okay, all right. Hashing is an alternative. What else? What other? Now even we can use mind map, face recognition, smart lock with connected Bluetooth device, smartwatch, mobile device management. Okay. All right, so we've got a plethora of options that has been suggested by the audience here, right? Now, all of you have given me an example of the different things that you would do in order for you to secure your mobile phone, right? Or your desktop or laptop kind of electronic devices, right? Now, question. There is one common weakness or disadvantage in every single option everybody has quoted here. Can someone tell me what it is? There is a pertinent weakness in every single solution that everyone has given here. When it comes to antivirus, when it comes to updating operating systems, when it comes to using a fingerprint scanner or a passcode or iris lock, any of this stuff. Well, at least with most of these things. Easily hacking. Well, I'm not really sure if that's true. Hacking something might be very, very easy in a movie. Might not necessarily be so in real life. Spoofing, okay, spoofing possible, but that's not a very easy thing to do. If you want to spoof something, you already need to have intelligence about that particular vulnerability. Okay, vulnerability in all solution. Yes, we are talking about vulnerability, but I'm asking what is the common point of vulnerability or a common disadvantage with at least most of the solutions that have been suggested here. Some of them aren't, but most of them are. Shoulder attack, just observe the code, what they type or do. Okay, fair enough. That could be a problem. What else could be a problem? All right, here is what I would like to do. I would like to summarize all of these solutions and say, with the exception of the antivirus and updating the operating system, right? Most of the solutions that have been given, right? Those solutions are all reactive solutions. None of them are proactive solutions. None of them are proactive in nature. None of the security measures that have been suggested are actually proactive in nature. Most of them are just reactive in nature. If you have an open screen, you can configure an unlock option using a pattern or a pin code or a fingerprint or an iris scanner, something like that, right? That's a reactive measure. Do you want to install a firewall, right? That's partially a reactive measure in most instances, right? Unless and until you've got an active cloud protection based firewall product, right? So all of these things are reactive measures. None of them are proactive. The only proactive measures are using some kind of a security software like an antivirus or malware software combined with a firewall, and updating the operating system, which can be configured to run automatically. Again, configuring updates in the operating system might be easy at a personal device level, but at an organization level, it is a very, very difficult affair. You cannot allow your employees to, update their computers, right, to the most recent patch version. That's not going to cut it, because then the code build for each and every operating system will be different, which means you'll never be able to deploy any applications uniformly across the organization, across the enterprise. That's going to be difficult, right? So this is where security automation comes into practice. Essentially, what you're doing here is you're orchestrating, right, the security automation space, right? So what ways are security automations being orchestrated, right? How exactly are we responding to that requirement? Well, one of the ways we are doing that is by actually configuring automation in our software, or sometimes even in our hardware, right? So what do I mean by that? What do I mean by automation when it comes to our software devices or hardware devices? Well, let me give you a very simple example, right? Okay, let me actually ask this question. Which year was the first time you actually used a computer? It could be any kind of a computer, desktop computer, laptop computer. Everybody give me a number. What was the year that you first used a computer in your life? I'll give you an answer. Mine was 1987. That was the first time I actually touched a computer. 92, 95, 2005, 91, 2001, 98, 91, okay, 93. All right, so it looks like most people have gotten access to computers probably in the early 90s, all the way to the mid 2000s, right? Now, if you remember, people from the early 90s, right? If you remember, most of you might have potentially used a Windows computer. Very few might have used a Linux or a Mac. So if you were Windows users, right, tell me what kind of antivirus software you used to use on your computer back in the days. Back in the 90s, what were the famous antivirus software? What did you use on your computer? Norton, okay, Norton is pretty famous. Norton antivirus. Norton antivirus is actually provided by a company called Symantec. So Symantec is pretty famous. Avast, yes, Avast is a very famous antivirus application. Kaspersky, well, I still use Kaspersky. That's what I use on all of my devices at home, right? Norton antivirus was probably the most famous. I would also assume the next famous, or actually the one that was even more famous than Norton antivirus, was actually McAfee. A lot of people used to use McAfee, right? Now, why am I talking about antivirus softwares from the early 1990s? Well, the reason why I'm talking about it is because I want to compare the way we used security products back then and the way we use security products today, right? Back in the 1990s, when you installed an antivirus software, it was your responsibility to go to the website that provided the antivirus software, and every day you had to go and you had to download some kind of a virus definition file, an antivirus definition file, and apply that antivirus definition file to the antivirus software. This was a manual process. This was a reactive process. In fact, if you remember, a lot of times there used to be virus outbreaks and computers used to get affected. And when, when computers used to get affected, we used to clean the files on the computer. Sometimes you had to format and reinstall the entire operating system and restore from your backups, right? When you used to do that, right, what used to happen was that you had to reinstall your antivirus software and immediately update the antivirus definitions to the current version. Now today, you don't need to actually go ahead and do any of that stuff. In fact, a firewall is built into pretty much most operating systems. So currently I'm using a Mac, but I can show you on the Mac. If I go to system preferences, for example, I can clearly show you that the Mac has a built-in firewall. So it's somewhere here. Let me try and show you security and privacy. There you go. So if I go here, see, the Mac actually has a firewall. It's turned on. So I can actually go ahead and configure this firewall if I wanted to. So there are options that I can configure from this firewall, right? I can allow, disallow specific items in this firewall. Of course, in my case, I cannot enable or disable anything. It's all managed by my company, right? But pretty much every operating system today comes with a firewall, right? Be it Windows or be it a Mac or be it a Linux machine, right? So Windows machines even come with some basic antivirus software. I believe it's called Windows Defender or something like that, right? So that's, that's where we are at. We are at a position where basic security for our computing devices is actually now being automated. It's being automated into the operating system or sometimes even into the hardware. A classic example of security automation in hardware is your fingerprint scanner. Today, if you buy any decent mobile phone that costs anything more than 15,000 rupees, you will easily get a facial recognition unlock or a fingerprint scanner on your mobile phone. So nobody else is able to, unlock your phone using, using some kind of a code that they would have overlooked, when you had unlocked it. So, that's the state at which security automation is at an end user level. So if that's the state at which security automation is at an end user level, think about the state of security automation on the enterprise level. So security automation today, fundamentally speaking, it leverages a lot of different technologies. One of the biggest technologies that it leverages is big data, right? So question, what do you understand by the terminology big data? What do you understand by big data? Answers go in the chat window. Give me an example of what you understand by big data. I'm not looking for accurate answers. I'm just looking for suggestions. Right, couple of suggestions here saying large volume of data, huge volume of data, okay, with high speed, combination of structured and unstructured data, terabyte data, 3V, volume, variety, and velocity, analyzing structured and unstructured data, okay? All right, so the way I would describe big data is this, right? Or rather, the way we can understand big data is this, right? Let's actually go to Wikipedia here and look at the definition of big data according to Wikipedia. Wikipedia says big data is nothing but the field that treats ways to analyze and systematically extract information, right? Or otherwise deal with data sets that are too large or complex to be dealt by traditional data processing application software. So the keyword here is too large or complex to be dealt by traditional data processing application software, right? So that's the example that is being provided here for us. So we easily understand that there is a reasonable amount of complexity that is involved when it comes to big data. It's not just large volume of data. Large volume of data has existed throughout the history of computing, right? Large volumes of data has actually been the case in any IT enterprise. Way back in 2004, 2005, when I started out in Computer Associates, I used to help customers run backups of file servers that were easily 1 or 2 terabytes in size. Today, 1 or 2 terabytes is nothing. 1 or 2 terabytes is not even the size of the hard drive that I have on my desktop computer at home. My desktop computer at home has a 12 terabyte hard drive. In fact, 5 of those, right, on a RAID. So, it's become pretty simple and pretty easy, to handle large volumes of data. Large volumes of data were never the problem. What actually was the problem was not just only large volumes of data, but complexity of the data combined with the volume of the data, right? Now, we take these large volumes of data, and what we do is we process it through a rules engine. A rules engine is basically any engine, right? Any kind of processing software that has some kind of business process or business logic that could be associated with it, right? A classic example for a rules engine would be something like a case management system or a workflow system, right? There are lots of examples for case management, for workflow, right? So I think I don't need to mention examples for case management. Pretty much, I'm sure all of you can, come up with examples. But we process, this information through a rules engine so that we can, make sure that it is compliant with whatever regulatory standards that are available, right? So in fact, I can actually tell you, right? Okay, what was the last time you heard of a major oil spill? Can anybody remember from the news the last time you heard of a big oil spill? What was the biggest oil spill incident in the recent past? Any examples? Anything comes to mind from the news? Where the oil spills were, what the oil spills were about?
Hello.
Hello, yes.
So the question is not clear.
The question is, when was the last time you heard of a major oil spill? An oil spill, oil leaking from a storage site or from a shipping tanker or something like that, an oil spill disaster. We've seen plenty of oil spill disasters in the past, right? When was the last time you heard of an oil spill in the news? Okay, Assam is one answer, Mauritius, Maldives, okay. Any other examples? When was the last time you heard of a major oil spill? Any year that comes to mind? Maldives, Mauritius is all small scale. Around 2010, yes, who was that? Srinivasa Subbarao. Yes, 2010 was the last time there was a major oil spill. In fact, it was the second largest oil spill, right? The first largest oil spill incident in the world was the Persian Gulf War oil spill, right? That was during the 1990s. I would have been a 10, 11-year-old kid back then. But that was during a war incident. During a peaceful time, right? The biggest Deepwater Horizon oil spill of 2010, that is the biggest oil spill, right? So yeah, April 20, 2010, that's when it happened. All right, does anybody remember why that oil spill happened? Any idea why that spill happened? What was the reason it happened? The reason why that oil spill happened was because someone did not apply compliance regulations to seals that were applied to a drill. So there was oil being drilled. There was natural gas and oil that's being drilled in the Gulf of Mexico. And what happened was that there was a cement well cap that was supposed to be installed, right? Now that cement well cap which was installed was not properly installed. And that well cap broke and the entire drill exploded, right? The entire casing exploded. And what happened was that the gas actually traveled all the way up to the riser platform, which is never the case, right? But it happened and it went on fire. It killed, I think, a few dozen people on the spot, unfortunately. And, that the amount of oil that was spilled was all the way from, the Gulf of Mexico up to Texas and Florida, right? The entire Gulf was coated with oil, right? So people say that, literally dozens, even hundreds of millions of gallons of oil and natural gas was leaked. And the entire spill, it spread over an area of close to 2,000 plus kilometers along the, US coast. So this was the BP's, British Petroleum's Deepwater Horizon accident that happened, right? Now, why am I mentioning this? I'm mentioning this because at that point in time, I was actually working for EMC. And when this spill happened, a lot of companies used to come to EMC to implement some sort of rules engine for their compliance management solutions. So compliance was a huge problem. The essential mistake with the BP Deepwater Horizon was that the wrong part number, the wrong kind of cement cap was used to close the enclosure. So the document that was being used was an outdated version of a document, which was the installation instruction used for installing the cement cap. And because the document was outdated, the part that was mentioned in the document, which instructed the actual welder who installed the cement cap to use an older model, an outdated model of the cement cap, which could not withstand the pressure of the drill. And when that cap was installed, within a few days, that cap exploded and the entire oil spill happened, right? So around that time is when, automation was discussed very heavily and people started taking automation as a serious alternative to compliance mismanagement, right? To make sure that compliance was not skipped over, was not overlooked, right? Now, with security automation, one of the salient features of automating any security infrastructure is that we ingest data real time, right? So we don't ingest data at intervals. We don't do a one-time ingestion. We monitor the situation real time. We ingest the data real time, right? And we make sure that all the automation principles are being applied to the data ingestion, as well as any sort of processing that happens on that particular piece of data, right? Another salient feature of security automation is an adaptive response. What do you mean by an adaptive response? Well, you see, um, sometimes when you dial a business, especially like a customer service hotline, let's say you come back from home, from your work, and you find that your microwave is not working. You try to call the company that sold you the microwave. Maybe you bought a microwave from Onida, and you try to call the Onida hotline at 7:30 in the evening, and you get a canned response. You get an automated message saying, the customer support hotline is only from 10 a.m. to 6 p.m. in the evening. Please call us during business hours, something like that, right? Now that is a static response. An adaptive response is something that will adapt to the scenario and provide a meaningful response for a particular given problem. A classic example for this would be the voicemail, the answering machine in your house. I'm not sure how many people used to use answering machines. I used to use answering machines back in the day when it was available. Well, actually, it's available today as well. It's just that nobody uses it because now we have all sorts of text messaging systems like WhatsApp and Telegram and all these things where you can leave a message. But before the advent of internet on cell phones, if you called somebody's phone number and they didn't answer, there would be a particular voicemail standard message that would come on. You could also configure, a customized voicemail message for different categories of numbers or specific numbers as well. That's an adaptive response, right? So what are all the use cases, right? What are all the applications for security automation? Where do we automate security incidents? Well, we automate security incidents in a lot of different places, but the most prominently used places where security incident reporting and automation comes into the picture is malware detection, right? So malware detection is essentially nothing but, you have a virus infection on your computer, right? Okay, let me give you this scenario. Let's see what kind of ideas people come up with. Let's say you're the IT manager in a company. Let's say you're the IT manager in Cognizant, okay? You're in an office building where 3,500 employees work, all right? One of the employee who is connected to the corporate network has a virus on their computer. They detect that they have a virus on their computer, right? You are the IT manager, all right? What kind of policies will you put down? How will you troubleshoot this problem and fix this employee's computer? Please tell me in the chat window. You can unmute and speak up as well if you think that's faster, or you can type in the chat window. How would you fix this problem? I'm repeating the question again. You're the IT manager of a big company like Cognizant. There are 3,500 employees in the building that you work in. One of the employees is infected with a virus, a popular virus, right, on their laptop, right? And you have to troubleshoot and fix this problem, right? What is the most effective and quickest way for you to troubleshoot and fix this problem? What will you do to prevent this problem from reoccurring? Disconnect the system from the network. Okay, all right. That's one suggestion. Fair enough. Removing the system. Okay. What else will you do? From the network. Okay. What else? What other options are there? Firework settings. I think that's firewall settings. Probably you meant that. Okay. Isolate the system and diagnose the network for virus. Okay. What else? Backup the data and format. Okay. All right. Any other suggestions? Reverse engineering of infection, understand the IOC. Okay. What else will you do? Reset the system. Okay. Running antivirus to detect. Delete temporary files. Okay. All right. We've got a couple of suggestions here, right? So let's work with the suggestions that we've got. Now, everything that you've said is fine, is fair enough. But there is a problem with all of this approach. The problem with this approach is that by the time the employee finds out that they have a virus, and by the time restore to an earlier working date, that would not work. That would not clean the infection. Unfortunately, that's not going to cut it. The viral infection is still going to linger. I think you're talking about system restore or some kind of a state restore using either Windows or Time Machine on Mac or any other third-party software. That's fair enough, but I think that would work for software inconsistencies, but it wouldn't work for virus-related problems, infections, malware infections. Okay, now think about this for a minute, right? Everything that you said is correct, but think about this for a minute. The employee takes about half an hour to 1 hour to finally understand why their computer is running slow, why there are endless number of pop-ups, why it is sluggish, why it seems to be occupying too much CPU power. All of this the employee takes time to understand and figure out, right? None of this stuff comes easily, and that's fair enough. But unfortunately, by the time the employee identifies that they have a malware infection on their computer, and by the time even they themselves proactively disconnect the computer from the network, which doesn't happen all the time, by the way, right? But let's say they themselves disconnect the computer from the network, this malware has used the corporate network and it has spread to at least 500 more machines in the network. What are you going to do right now? Are you going to shut down the company? What now? By the time the user figures out that they've got a malware infection and walks over to the IT help desk, let's say this employee, he or she is sitting on the first floor, and the IT help desk, they usually sit on the topmost floor of the building, right? General security best practice, right? So they're sitting on the 7th floor of a Cognizant-like building. By the time this person carries their laptop and goes to the elevator, presses the button, waits for the elevator, takes the elevator, goes to the 7th floor, finds somebody in IT and talks to somebody in IT, right? And disconnects the computer from the network, 500 computers on the network have already been infected. And by the time you've logged in at least 50 more computers into the service ticket management system, guess what? All the computers in the network are infected, including some of your server machines. What do you do now? Shut down your website? Well, you see, things should have never gone that far in the first place. Now, things will never go that far in the first place in today's scenario. In today's scenario, right, a user will not need to sit and wait for understanding, detecting that the user has a malware, right? One only needs to have non-standard suspicious behavior on a particular node, and we can automatically automate the disconnection and the blocking of the IP address and also the MAC ID, and also physically sending a ticket or an email or some kind of a notification like an SMS notification to ask the user to disconnect the machine from the network immediately after you block it. And also you'll automatically raise a ticket in the support ticket management system as well. So that's a classic use case for security incident orchestration automation. Another place where you would use, security automation is penetration testing. You'll build applications and you'll try to penetrate your applications using thousands of different random ports and hundreds of different techniques, right? All the way from brute force attack to DNS attack to denial of service attack to everything. Now, another use case for security automation is compliance. Like I said, the BP oil spill, if they were compliant with applying a particular rules engine and making sure they didn't have caps in compliance, the 2010 oil spill would have never happened. Right? Performance is another place where automation kicks into the picture. Right? What if, let's say, your hard drive is filled up to 80%? What do you do then? Well, you might automatically move some of the older files that you don't use into archive. That might be a good idea. And once you move it into archive, you actually have additional free space that's available for you to work with. Right? So that's performance automation. Now, there's a point here that I've mentioned. I've mentioned detonation here. Right? What do you understand by the word detonation from an IT security point of view? Has anybody come across this terminology called detonation? I'm not talking about detonating a bomb or an explosive device in warfare or, in some kind of a Hollywood terrorist movie. I'm talking about detonation from an IT security perspective. Has anybody come across this terminology? Anybody understands what exactly is, detonation is? Detecting the malware, okay? What else? What else do you do apart from detecting the malware automatically? What do you do? You've detected the malware already, right? Now you want to detonate the malware. How do you detonate the malware? Detonation is a rapid and violent combustion. Yeah, that's the English meaning of detonation. We're talking about the IT security concept called detonation, malware detonation. Quarantine, okay, all right. Activating the malware, okay. All right, so detonation of malware is nothing but what we actually do is we take the malware, we copy the malware to a sandbox. Now this sandbox will be a fenced environment. It will be an isolated environment. Once we copy the malware to the sandbox, we actually delete the malware from the source system. We completely delete the malware. We do like a block level erase of the malware file or the malware code. We then go to the sandbox and we try to activate the malware by actually interacting with the malware. Now that malware, what it will do is it will try to run its code. When it tries to do that, you will try to capture the malware code. Once you have done that, once you've analyzed the fingerprint of the malware, what you'll then do is you'll safely go ahead and delete that malware code from the sandbox, or better, you'd completely end up destroying the entire sandbox. So what you have right now is you have a safe piece of malware code that has been extracted, that has been fingerprinted from the malware. The malware has also been completely eliminated from the environment. This is very akin to what a bomb detection and disposal squad would do in real life. I mean, if somebody plants a bomb, let's say there is a war going on in some country, right? And let's say some very evil people planted a IED on the roadside. The bomb disposal squad will be called. They're not going to just come and defuse the bomb and walk away. No, they're going to not only detect where the bomb is, where the IED is, they're going to defuse the bomb. They're going to safely dispose away the explosive material. They're also going to document what exactly happened during that disposal, right? And they'll also go ahead and figure out how to prevent, such incidents in the future. They'll pass on their learning to the actual people who are on the ground, right? Maybe the soldiers or the security forces, so that the next time they can figure out, they can identify such problems with ease. That's what a detonation is from a malware point of view, right? So those are all typically the applications, right? When it comes to security automation, orchestration response. Now, typically in any SOAR platform, we run something called as a playbook. Now, this playbook is nothing but it is a codification of all of your logic. Whatever business logic you want to deploy, we write this business logic in code, and then we try to the best of our abilities keep the code visual in nature instead of getting down to the actual code. Typically, it is Python code because it's because for its simplicity, it's Python or Java code. And once we have this code, we ensure that this code is modular in nature. Because it's modular in nature, it is also pretty reusable in nature as well. You can keep reusing the code over and over and over again in different circumstances and different scenarios, right? So that's essentially what playbooks are. Playbooks are the digital codification of any of your business logic. So what I am going to do is this, right? I am actually going to go ahead and show you a demo. So I'll show you a simple demo where I'll do a file and domain name analysis, right? And then what I'll try to do is I'll also try to show you an escalation matrix as well, right? So this escalation matrix will decide who is going to do what depending upon a particular scenario. All right. So it's a very quick demo. I'm not going to take anything more than 5 or 10 minutes to demo this. And then, of course, we still have 19.5 minutes. So I'll try to demo this, and then we'll still have time for question and answers, right? So we'll actually see how, practically speaking, how a security automation orchestration response system uses a playbook to codify business intelligence to deal with a security threat. All right. So let me go to the environment here. So I have a lab environment here. So let me go to my lab environment. And in this lab environment, what I'll do is I'll try to import an event. I'll try to import a container. So this event is actually nothing but it's a record of some security incident that is, happening in the environment. So let me import this container here. So this is an event that contains details about a file that was downloaded via HTTP. So we are using our browsers and we are downloading files every day on a daily basis, right? What we want to do is we want to understand how exactly this thing works. So all right. So this is my event. It contains a lot of information. It contains useful information. What useful information does it contain? It contains information like, for example, the file path where the file is stored. It contains the source address where the file came from. It contains the destination address, which is this local computer, the source URL where the file came from. In this case, it came from google.com. And then it contains a unique hash value for the file, which is used to detect whether or not this particular file is malware or not. So what I am going to do is I am going to go ahead and set up a simple, playbook, and this playbook is going to analyze this particular event here. So let me try and let me design a particular playbook here, right? So I will go and I'll first configure to use a particular cloud-based service called VirusTotal. VirusTotal is a very interesting service. So what this service does is it analyzes hash values, right? And I make use of an API key. So I'm going to configure the VirusTotal cloud service to actually do all the analysis for me. So let me check here. I'll have a VirusTotal app. This VirusTotal app, by the way, the tool that I'm using here is called Phantom. So it's a tool that is available with my company. I can supply the VirusTotal API key, and I'll save this asset and I'll test the connectivity, and the connectivity test has passed. So this app is now configured. Now, what I'm going to do here is this, right? I am going to go ahead and I'm going to configure a simple playbook. Now that playbook, I'll need to go into the playbook editor for me to create a playbook. So by the way, I'm going to write very, very minimal code here. I'm not going to write that much of code at all, right? So I'm going to go ahead and create a simple playbook plus playbook, and I'll launch the playbook editor here. Now, this is a visual coding system. I don't even need to know, full-on Python coding. I can use the visual playbook editor, and I can call this, for example, the investigation process. So I'm just going to run a process for investigation. And what I'll try to do is I can turn on logging here, right? And I am going to put an action block. The action block is basically going to make use of an app called MaxMind. MaxMind is an app that determines the location from where the file comes from. So in my case, I'm going to determine the location of the file. So let me see where this file needs to come from. All right. So this file actually needs to come from source address is the address that I need. So I'll end this playbook here. This playbook contains only one action. Now, if I run this, right, it will go ahead and it will tell me what is the source of this file. Look, this file was downloaded, right? This file downloaded by HTTP. This event was created because that file was downloaded, right? Well, it'll tell me where the file was downloaded from. In fact, I can even look at the backend code of this application as well. So if I go to the code, look here. This is actually Python code. You can see that the system has automatically written the Python code for me, and it's passing the container data to the action that I'm using. So the action here is nothing but it's an automated method that we are trying to use to determine what is happening in this environment here, right? So I'm going to save this particular, and I'll say geolocating the file that is being downloaded. So I've just put a comment there. Now I can debug this. Now every container, this container also has some data in it, right? So I can actually see what is happening with this container. Let me expand this container so I can see it. All right, event info, I can see that the container has an event ID. It's event ID 9. So I'm going to use the event ID to debug this particular container. So I'll go ahead and I'll say test. When I test this, look, this process has run and it has given me in the debugger, it has given me the results. What are the results here? Let me expand and show you. Look, the geolocate IP code is run and that code is successfully determined that this IP address for this is 8.8.8.8 and it'll also tell me where this particular file came from as well, right? So it clearly tells me where exactly this particular file has come from, right? So it can tell me what that country is. Look, the country is, it's coming from United States. Do you see that? Now, this is simple, very, very simple automation. I can run playbooks like this. For every file that is downloaded, I can download a particular file and I can determine where that particular file is coming from. In this case, it comes from the United States. It's a safe country. I don't need to do anything to it. But let's say, for example, if it was, a very suspicious country, what if the file came from a very suspicious country like North Korea? That country is prone to, hacking other, countries. It's a rogue country, right? So obviously, you would want to automate some decision making, some response on the basis of whether or not, if that file is coming from North Korea or whatever. Now, not only that, what I could also do is, look, anything that I do in a simple security automation tool is quite comprehensive in nature. I can even debug, items here as well. I can edit this playbook and I can go to the backend code and I can even enable a simple debug here. The debug options are already available to me here. So I can actually, get rid of all this commenting on this code. This is simple Python code. I mean, if you're familiar with Python, you'll know what is happening here, right? It's just passing the JSON summary results here. That's all it's doing, right? So I'll just save this, right? Added debug to output results. So if I run the same debugger with event ID 9, now look what is happening. Something more interesting is happening. I now have debug data. This was not available earlier, but now look, the entire code is now being debug output in JSON. See, country, United States, status is success. IP address that I passed was 8.8.8. It also has a unique GUI ID because of this IP as well, right? So this is the actual result that we get. Now, this is a simple automation scenario where I'm finding where, a particular file is coming from, right? But what I could do is I could also go ahead and I could have some other, more complex scenarios as well. What kind of scenarios can I have? Well, let me edit this playbook and let me add some additional features here, right? What can I do over here? Well, I could go ahead and I could just go ahead and let me think. Okay, let me add some domain reputation. The place where this file is downloaded from is a domain, right? So I'll go to the VirusTotal app and I'll say domain reputation because these methods are available to me. And what I want to do is I want to get the domain value over here. So the domain value that I'm going to use is source DNS domain, right? So connect this, save, and then automatically checking domain reputation. Now this domain reputation will have a score, right? So let me show you how that score is going to be. I'll go back to my debugger. I'll run this debugger. When I run this debugger, notice my domain reputation now runs let me go. See what happens right now. Domain reputation is being run. It is succeeded. And look what happens. See, this is the action ID. This is the run. Detected URLs 100. Alexa rank 10. Download samples 100. Communicating samples 100. See, there is a rank. The total positives is 0. The total objects is 1. So there were no suspicious domains that were detected in the total positives. The Alexa rank here was 10. Which means, it's a decent rank, right? Anything that has a rank of something greater than 50, something like that, then maybe I need to go ahead and do something about it. Is that all I can do? No, actually not. I can actually do more as well over here, right? What can I do over here? Well, let me show you what else I can do. I can edit this playbook here, and I can also go ahead and add another automation, right? Which is I will go ahead and do using VirusTotal. I'll check the file reputation, right? File reputation. So I'll go to artifact, CEF, file hash. I'll pass the file hash value. So now that I've added file reputation, automatically checking for file reputation. So this is my file reputation here. So if I now run this again, look, domain reputation is running, file reputation is also running here. Look, I can easily see file reputation succeeded. This file reputation also seems to have a positive. Total scan 67, positives is 28, right? So obviously, this file reputation also has come up with a file reputation score here. In fact, I can detect all of these items here in my, look, I can even get to the debug log as well over here. I can get to, for example, I can go to a method and I can get to see everything in JSON. See, all this output is available to me in JSON today. See, beautiful. I did not have to write a single line of code. All I had to do was design a playbook and run that particular playbook against a particular file event. And when I got that playbook down, right, I easily could go ahead and figure out what was happening. Right now, the cool thing here is I can also rearrange the way in which this rules engine works. Look, this is all a rules engine at the end of the day, right? So I can redesign the rules here of the game. So I can go and say, for example, delete this, delete this, delete this. So I can go and I can do this. I can just do this, do this. All right, so pretty cool, isn't it? I can actually do parallel processing here. So instead of sequentially processing all this information, I can just do parallel processing, and there you go. See that? You can clearly see that this is running actually faster because the processing is happening in a parallel fashion. And you can see that I'm getting exactly the same results, but there is no parallel processing that is happening here. This is what we call a playbook in a simple security orchestration automation system. Now, I can also have decision making and conditional logic as well come into the picture here. Like, for example, right, if I go and I'll just expand this here and delete this. right? Now, what I'll try to do is I'll try to use the file reputation as an example. And in this file reputation, what I'll try to do is I will try to bring in some logic. What kind of logic do I want? I want a decision-making capacity. So I'll add a decision block, and that decision block is going to be followed by a user prompt block. And what I will do here is, I'll connect. Well, I don't need to connect all of this. Let this wait here. So in the decision block, what I can do is I can simply go ahead and I can say, what can I do? I could say file reputation, summary positives. So if this summary positives is going to be greater than 10, right now I think it's 37 or something like that, then what I need to do is I need to go ahead and go on to the prompt block. Now, if it is not a positive, right, I'll add a else condition. I'll just directly go to the end block. I'll just directly go to the end block here. I won't go to the user prompt, right? So I'll just go ahead and connect all these things together. All right. Now what I'll do is in the prompt block, I'll add a prompt here, and the approver is going to be myself. And I'll add a prompt and I'll say, a potentially dangerous file was downloaded. It came from a server with IP address. And I can add a parameter here, right? The parameter here will actually be something along the lines of artifact CEF destination address. That's the destination address parameter. So it's going to be a yes or no message, right? Then do you wish to escalate to the IT team? That's what I want to do. All right. Now that I've got that in place, what I can now do is I can easily go ahead and I can just go ahead and let's see. The typo here, correct this typo. That's it. So decision making added. Okay, so I've come to the end of my demo. My timer is also, reminding me here, right? So save that. Now, look, if I try to run this, what's going to happen is automatically, because the score is greater than 10, I automatically get a notification here, and I did nothing. This is just automation. I can now say yes or no. Do I want to escalate to IT team? Yes or no? I can say yes, and I can complete. And there you go. That's the security automation that we were talking about. So if something like this happens, right? If something like this is going to happen, right? This is automation. Even before, just immediately after the file has been downloaded, I can run a scan and I can say, hey, you know what? This looks like a virus. This looks like a malware, right? If this looks like a malware, do I want to escalate this to the IT team? If I want to escalate this to the IT team, I want to send it to a specialist. The specialist can review the file and say whether or not it really needs to be sent to the IT team. What if it's a false positive, right? I don't want to waste someone's time. So this is a very, very simple and straightforward example of automating security response to a given scenario. And everything you see here is just simple, straightforward Python code right here. See? If you want to play around with something like this, you can do that. There is a free version of Phantom that you can download. Go to splunk.com. I'm pretty sure you'll be able to download the free version of Phantom, and you can install it on your laptop or on your desktop, and you can play around with this. You can install this on a Mac, on Linux, on Windows, pretty much anywhere you want to, right? So that is what we did. We saw a file and domain analysis example first, and then I developed an escalation matrix for that security threat that I downloaded. What did I download? I downloaded a file via HTTP, and I ran a scan using a cloud-based virus scanner service, right? And that virus scanner service gave me a total of 10. My tolerance limit for positives is a 10 rank. So because I hit a 10 rank, I automatically sent it to an IT guy and I asked, hey, you know what? Potentially dangerous file was downloaded. Do you want to escalate this to the IT team? That's what I did, right? So that's a simple rudimentary example of security automation and orchestration of a response to a security incident. All right. So what time is it right now? It's 3:17. All right. I've slightly eaten into my Q&A time. Sorry about that. But in the interest of being detailed. So that concludes our simple lecture and demo on how you can automate your response in the security space. You can orchestrate a security response via automation, right? So any questions so far? If you have any questions, please go ahead and ask. You can put it in the chat window. And okay, there is a question here. Is Splunk open source? Splunk is not open source. It's a proprietary piece of software. So, but there is a free version of Splunk available. You can use it for educational purposes. So download it, install it, and use Splunk. The tool that I used was not Splunk. The tool that I used was called Phantom. It's called Splunk Phantom. Phantom is the SOAR tool. So you can go to Splunk and you can look for Phantom. Another question on the chat window, what are the disadvantages of Splunk? Well, it's a tool. I'm not really sure what do you mean by disadvantage of a tool. There isn't anything really in terms of a disadvantage or an advantage of a tool. It depends upon how you use it. But if you're looking for, pros and cons, the only con that I can think of when from a Splunk or from a Phantom perspective is that it's a licensed piece of software. So obviously you need to, you'll need to purchase a license if you were to use this in an actual enterprise scenario.
On behalf of the Department of Computer Science and Engineering and the team, I would like to express our appreciation and gratitude for your insightful presentation. The session about the security orchestration, automation and response and the demo by Mr. Dilip Muralidharan was extremely informative. It was a pleasure to have you with us, sir. Thank you for the excellent presentation.
Thank you for having me, everyone. Have a nice evening. Thank you.
Thank you, sir.